Good afternoon, everyone, and thank you for joining us. We're really excited to have you here. My name is Daniel Jacobson, and I'm a program manager on the Visual Studio team specifically focused on tools for Windows developers.
And my name is Olia Gavrish. I'm a program manager on .NET team working on WinForms and porting to .NET Core.
And today we're really excited to share with you what's new and up and coming with .NET desktop development and Windows 10, and we hope there's a lot you can take away to leverage in your own application development. To start, we're going to provide a little bit of context to frame the rest of the conversation we're going to have today. And then we'll talk about upgrading .NET desktop applications. Then Olia will go into detail on how you can leverage some tips and tricks to more easily migrate existing .NET Framework applications to .NET Core. And then we'll introduce you to our roadmap and leave some time for questions and answers at the end. So setting the stage, providing a little bit of context. If you've been building .NET Windows applications, you've probably had to make a choice between WPF, Windows Forms, or UWP in the past. When thinking about building an application for Windows, these really aren't the platforms that you're targeting. The platform that you're targeting is Windows, and you should be able to leverage all of the capabilities of Windows when building an application running on that platform. Not only that, but when you do optimize your application for Windows 10, you will get more modern innovations in the platform capabilities that your applications can leverage. So rather than thinking of Windows Forms, WPF, and UWP as the platforms that you're building applications for, think of Windows as the platform and those as the UI frameworks. In any Windows application, you can now leverage any one of the UI components from all of these, so long as you're running on the version of Windows 10 that supports Windows 10 XAML. But if you were at the presentation platform discussion earlier today, you'll see we're even doing work to bring some of that down level to earlier version of Windows 10. So we've heard the community loud and clear. We know we need to bring some of our more recent innovations down level, and we are doing that work. So we're excited to share more there. Not only that, all of these UI frameworks are now open source and built around the community with community voice, input, contributions, PRs, issues, you name it. And we want to hear from you, and we want to work together to build the best client platforms. That's the context. So we're building applications for Windows. We're not talking about WPF, UWP, or Windows Forms. We're talking about Windows today. So now let's talk about upgrading .NET desktop apps. What does that even mean? What do we think about when we talk about upgrading applications? Well, there's a couple different things. And as this slide progresses, the one thing I want you to take away is each of these are options you get to make when building applications. None of these are forced upon you, and you don't really need to use all of them or none of them. It's up to you. There are a couple of dependencies for some of them, but for the most part, they're separate. The first one is a modern runtime with .NET Core, with more modern runtime characteristics, performance optimizations, more frequent updates, you name it. Next is easy access to platform and device APIs on Windows 10, such as Bluetooth APIs or your geolocation or things like that were traditionally difficult to do in .NET Framework desktop applications or Windows Forms WPF. Next is modern and accessible UI and input with XAML islands. All of the platform controls in Windows 10 support natural user input, so text, voice, inking, you name it, touch, and now you can leverage those in your existing .NET desktop applications. Further, seamless application deployment, updates, and optimized for DevOps. The entire .NET end-to-end toolchain is really designed with DevOps in mind and CI pipelines in mind. And there's a great talk about that tomorrow, but we'll talk today about seamless application deployment and updates, behind-the-scenes updates, more like the web deployment model, where all of your users can get the updates without really any interaction, which is awesome. And finally, and perhaps most importantly, what we've been hearing from so many customers is really just the ability to innovate at a developer pace. Just by show of hands, how many of you had to wait to adopt a later version of .NET Framework in your applications simply because your enterprise wasn't updated to that version of .NET Framework? Exactly. So with .NET Core, that goes away entirely. You can update at your own pace. And so rather than thinking of this slide as the list of upgrades, this is why. And if you need to convince management or whomever, like why you should invest in doing this, here's your answer. So for the next 25 minutes or so, we'll do demos of each of these. We'll talk about some case studies and how you can incorporate these into your own applications, starting with modern runtime, BCL, and features. Let me make sure I do the right one. And so I figured it would be fun to start this demo with a game. And so we're going to play a game, choose that runtime. And so I've got an application that's already compiled. It's in assembly. And I'm going to run it against both .NET Framework and .NET Core. And I'm going to ask you to tell me which one is which. I'm also on the Visual Studio team, so productivity is like I get really excited about it, so I hope you can learn something new from me about productivity, starting with this one. Did you know that in Explorer, if you type CMD, it'll launch your command prompt to that path? Just a little tip and trick. Every time I do that, someone learns about it, and I'm like, it's the best. So I'm just going to start by running pysample.exe, and then I'm going to use .NET exec, the same executable. And then I'm going to just mix these up a little bit so you don't know which one's which. And now I'm going to go through this application, and I want you to figure out which one's framework and which one's core, so pay attention. You may notice some different behavior. So this one is good. And what this is going to do is it's going to enumerate files on disk. It's mostly a file I/O application. So let me go here. There we go. And I'll go 2 levels deep for the recursion. So the one on the left, who thinks that is running against the .NET framework? Who thinks it's running against .NET Core? Correct. So the key takeaway here is mostly the functional behavioral difference. One of the first community accepted pull requests we took for Windows Forms was to modernize this folder picker dialog to use Windows Explorer rather than that old tree view option we had before. So that's the runtime behavior difference. Also, if you look in the bottom right, you can see performance characteristics. Since this is primarily a file I/O, it's just reading files on disk, .NET Core is going to execute a lot faster at runtime here. So it's almost twice as fast performing that file enumeration.
And actually, when Daniel was showing me that, it was 4 times faster. So
sometimes clicking it changes it, doing it more than once. Whoops. Let's see. 187. So
here you go.
Yep.
Yeah.
Let's go back to slides for just a sec. And so the way I'm actually doing this is with a, whoops, we lost slides. I pressed the wrong button. My apologies. So with .NET Core, you can specify this runtime config file that enumerates which runtime the application is going to run against. And so the most simple test to see if your application is ready for .NET Core is to essentially create this file, name it the executable name .runtimeconfig.json, and then do .NET exec on the command line for that assembly. And it may crash, it may not work, depending on what APIs you're using, but this is just a good test. Does it work? I would not deploy this in production. This is just a, hey, does it work kind of thing. In addition, when thinking about performance optimizations in the .NET Core runtime, it helps to think about the origins of .NET Core and what sort of workloads it was optimized for in the very beginning, which is primarily server workloads, ASP.NET Core 1.0. So thinking about what performance characteristics are really important for .NET Core, file I/O, networking, database operations, things like that. For desktop applications, those performance benefits will accrue to your apps as well. Things that you may not see immediate performance improvements on are startup performance and UI rendering for now. .NET Core releases quickly, and right now we're just trying to build a product to release. Over time, we're going to continue making it better and better. And now talking about a customer many of you may already know, National Instruments. So we've been working with National Instruments in a roadmap and strategy for migrating their product LabVIEW to .NET Core, which is a .NET Framework WPF application today. And their primary motivators for now is that this is a huge critical application for their business. It's not going anywhere. It's not like in maintenance mode or anything. And they want to kind of future-proof their application with newer language features, as well as accruing the benefits of .NET Core runtime improvements as we release more and more updates. In addition, just one new language feature that they're really excited about coming to .NET Core that won't unfortunately be available in Framework due to missing dependencies is default interface implementations. And that is something that should help them improve their developer practices within their business. Next is access to platform and device APIs on Windows 10. Again, this is something that you used to be able to do, but it was a really challenging scenario. And so let me show you how we've made that a lot better. Before that, I just want to introduce the primary application we're going to be working in. I have a .NET Core 3 WPF application and a Windows application packaging project. Nothing is hooked up yet. It's just a blank app just to kind of speed things up because there's a lot I want to show you. So the first thing I want to do is I want to show you how to get access to the Windows 10 platform APIs in a .NET desktop application. In my .NET Core WPF app, I can go to Manage NuGet Packages and search for Microsoft.windows.sdk.contracts. When I download this NuGet package, that's it. So now all of a sudden I have access to all of the platform APIs available in that version of Windows 10 specified by the version of this NuGet package. And so the one I want to use, we're going to build up a little simple map application that's going to essentially zoom in on where we currently are located. And so to do that, first, I need to get our coordinates. Where are we located? So let's go ahead and build up a simple UI scaffold to essentially click a button that's going to find our location. And again, I'm a productivity guru, so I want to show you a couple cool new features in Visual Studio. First, if you have not used IntelliCode for XAML, you see those stars? It is probably the #1 feature in Visual Studio that's improved my XAML productivity. It's machine learning-driven IntelliSense code completion, and it works amazing for XAML. So, for example, if I do column definitions, of course, the first thing it's going to recommend is column definitions, and then if I do that, it's going to recommend the properties that I would typically set when doing my scaffolding. But I've actually already got this code prepared. So let's start just by running the application. And now you're saying, wait a minute, you haven't written any code. Why are you going to run the application? Well, another feature that many people aren't aware of that has been around for some time is a feature called XAML hot reload, where you can actually edit XAML as the application runs. So let me put Visual Studio to the side, open up my snippet. Let me copy that. And now check this out. Just like that. My simple scaffold is there. Everything on the left is going to be where I'm getting my geo-position data, because I'm going to put a map on the right. And so XAML hot reload lets you build and edit and modify your XAML at runtime, so you don't have to worry about sample data or anything like that. You can work with real data coming from your app. So now I have a button that I just put in with XAML hot reload. So let's navigate to the event handler and go ahead and add in the geolocation APIs that I need to do. Another cool trick, Control-KD formats the document. If you want to go ahead and clean things up, especially as you're copying and pasting or just quickly writing code. And then with Visual Studio, I can Control-Dot to add in the missing using statements. And because this is calling an asynchronous method to get my location, I'll make it an async method. Just like that, those 6 lines of code are going to essentially find my location, print it on the UI, and format it so we don't get a bunch of trailing decimals. So let's test it to make sure it works. And it'll take just a second because it's async. There we go. Come on. There we go. Cool. So that's where we are. If you want to look at your map now, you're welcome to. But if you just want to wait a couple minutes, we're going to put a map in next. So to get access to Windows 10 platform and device APIs, just a NuGet package now. When you want to update it, you're updating a NuGet package. So the recap, that's where you can find it. Again, we're building this with community input. We just published a blog post about this. If you have feedback or issues trying to use this, do let us know. And again, going back to the case study. So we've been working with another company known as SetPoint Medical, and they are a biomedical technology startup building an implantable medical device that stimulates the vagus nerve in your body to help dramatically reduce the symptoms of many autoimmune disorders. They use WPF for device testing, and for the longest time, one of the devices they had a physical USB port, so they were just using a USB library to be able to communicate to this device. As they kind of ramped up and grew, they started building new devices that replace the old ones that have no physical ports for durability, for water resistance, things like that. And so the only way to communicate with this device is with Bluetooth. They actually built their own custom USB Bluetooth dongle as a temporary hack to communicate to these devices because they couldn't find a suitable Bluetooth library in WPF to talk to these things. And so we worked with them and we showed them how they could do this. And using the built-in Windows 10 Bluetooth APIs, they can reduce the need for that dongle. They no longer have to maintain it or get regulatory approval because it's a medical device. Everything they do has to go through the FDA. And so that's, I think, a really cool story of how this technology is really helping this company be more productive in building solutions that help people. Next, modern and accessible UI and input with XAML islands. So let's go back to my screen, which is 2, and add a little bit to this. So I've already added one NuGet package to my project. And let's go ahead and take a look at a couple more. So I think I actually saw him in here. The developer that works on this is the Microsoft Community Toolkit. He's excited. You want to say hi, Alex? Wave, everybody. So this next NuGet package is from the Microsoft Community Toolkit team. And essentially, they built a couple of useful utilities for consuming XAML islands. So if you search Microsoft Toolkit WPF, there's also the WinForms equivalent. Again, we're talking about Windows, not UI frameworks dependencies, but this is a WPF app. there are a couple different NuGet packages. One is the controls NuGet package, which is a set of controls that we've essentially pre-wrapped for you and exposed all of the APIs that we think you would actually use for those controls. So it's just like a WPF control, the way you actually program against it. The other one is the UI XAML host control, which lets you build your own custom XAML islands using any of the Windows 10 platform capabilities. And again, this is open source and developed with the community. So if there are controls in this package that you don't see that you think should be there, let Alex know on GitHub, and I'm sure their team will add it in a future update. And so fortunately, they do have the map control in this package. So I'm just going to use this package. And so this is where there is one additional dependency if you do want to use XAML islands. You need a package identity, or an app identity, if you will. And so fortunately, we have tooling that makes it really easy, which is the Windows Application Packaging project. If I add a reference to that app and set this as my startup package, now it's running as a package. And the reason you need that is because the XAML runtime will shim the behavior based off of your max version tested property, so that as Windows iterates and XAML behavior in the platform changes over time, your app won't break. It's going to continue to essentially run as if it was built for that version of Windows. With the future of the Windows presentation platform decoupling from Windows and going down level, this will probably change and be easier for you in the future. The last thing I want to do in the Windows Application Packaging project is I want to make a self-contained application. This is just a point-in-time thing because this is early pre-release bits. We're going to do this for you automatically in the next version of Visual Studio. So now what I need to do is I need to actually add in the map control. So let me close all this stuff to run faster. And another fun feature in the XAML editor that we added, talking about productivity, is automatic namespace completion. So this is especially helpful if you're like copy-pasting code from one file to another and you don't have all the correct usings. We have that in XAML now, which is really nice. And so I'm going to use the map control from the toolkit. Notice I get this type from both the Windows platform and from the toolkit. The toolkit version is going to be optimized for development in a WPF application. So then I can specify a couple properties. The reason I really like the Windows 10 one is I can get traffic flow information. I'll give it a name, call it the map, and then I'm going to put it in the second column of my grid. And so now what I want to do is I want to just position the center of the map to where we just found, right? The map.try_set view async, and then this takes in a couple parameters. It takes in a geopoint center, or you can overload to also zoom in, so I'm going to do that. And I already have this point. If you look above, I can do position.coordinate.point is my point, and then I'll zoom in at a level of 15. And again, this is an asynchronous method, so I'll await it. And now I'm running this. And so now the runtime of this application will be slightly different because it's in the Windows Application Packaging project. But I can pretty much do anything you would expect to be able to do in a WPF application in the Windows Application Packaging project, depending on some of the settings you set. But by default, we're trying to be as least restrictive as possible because we know how much you need the power and productivity of the desktop. And so once this runs, you should see the map rendered zoomed out. I didn't actually enter in an API key. But now when I click Find Me, not only will you see that longitude and latitude, you'll also see it zoom in on the map to where we are right now. Hey, look, it's us. Oh. And as you can see, Seattle traffic can sometimes be pretty red and scary. So let's go back 2 slides. So talking about XAML islands. Depending on what you want to do with XAML islands, things can be extremely easy like that. We can do a little bit more complex things, which we'll actually do in a moment, to pretty much build any sort of Windows 10 form or control or whatever you'd like in a WPF or WinForms application. So if you're thinking about the future of your app and you want more fluent UI and fluent styling, this is kind of a great way to get there. Now, these next slides may look scary, but they're only to make one point, so I'll try to simplify them. This is coming from the future of the presentation platform talk, which gets into more of the intricate details of how this all works. But what I want you to take away from this slide is all that green stuff at the bottom, the XAML framework, hosting API, inbox controls, et cetera, that are currently built into Windows at an OS level are essentially being decoupled and put into the WinUI package. And so all of those things will enable the team to iterate more quickly, bring those packages down level on Windows 10 so you can consume them more, hopefully sooner, because your customers are going to be on those versions of Windows 10, and deliver value to you as you work. And again, you'll probably notice a theme. WinUI is being developed in the open. So if you have feedback, comments, concerns, issues, let the team know. We're pretty much doing all of this stuff for you. So the next one, now we're talking about deployment. This is the fun one because we always get a lot of feedback on how much pain there is deploying desktop applications. So I added this Windows application packaging project just as kind of a step, but let me show you what that actually looks like if you were to add a project to Visual Studio. We have a template called the Windows application packaging project that gives you that project, and that handles all of your deployment settings, including automatic update settings and things like that. So let me show you what I mean. If I go to Store, Create App Packages, the first thing I'll notice is, how do I want to distribute my application? Do I want to go through the Microsoft Store? Or do I plan to sideload this application with my own enterprise deployment solution? I'm going to choose sideloading, and I'm going to enable automatic updates. I'm actually going to output this application to my desktop. This could be any UNC path, which we know is a common way to deploy applications in an enterprise, or it could be like a web place if you have access, like a web URL. And then you can also specify where you want the installer to be hosted. And so in my case, I'm doing the most easy solution, deploying to a location my machine has access to, and then also hosting the installer in the same place. And so every time I create a new package update, my app will update behind the scenes. So let's go ahead and create this package and install the app from the package, and then we'll add a new update. So why don't we add in a custom XAML islands and have the application update behind the scenes without me having to do any other update actions. So first, and the reason this is actually taking a moment is because this is a fully self-contained package. The entire .NET runtime dependency will be included in this package, so you don't have to worry about what's on the machine before you install it, and you don't have to worry about chaining in some .NET installer. This has it all in there. But that's the next demo, so we'll get there in a sec. So the first thing I want to do as well is I want to uninstall the developed version of this. This is what I did when I F5'd and installed it, because I'm going to install from the package. And so then I will open the output location of this. And you'll notice we actually create a couple of different things. First, we create this app installer file. We create an index.html for you that you could then customize if you wanted. So you can host this like a SharePoint link or some intranet site for your enterprise. And then you can instruct your employees to just get the app. So it's as easy as that, and then it's going to install. And just like that, I'll have the same application we just built. But that's not the fun part. The fun part is really the automatic updates. So let's launch this just to make sure it's working as we expect. Find me. And so it should zoom in on us. There we go. Great. So same application, now deployed through a more formal app, through the actual MSIX package. Now let's go ahead and put in an update. And so I'm going to do a custom XAML island control, which for now I'm actually just going to do a text block, because I think it gets the point across without being overly complex. But there are a couple things in WPF text blocks that you can't do that I think are kind of sad. So let me do this first. And so let me talk through this XAML a little bit. I'm using the XAML host control. Again, coming from that Microsoft Community Toolkit package, which allows me to essentially instantiate any Windows 10 platform control type name by type. And so this is, again, like a WPF control that has an initial type name property that will then load in that type. And then what you can do is you can create a child changed event. And every time the application loads, it's going to call this event for the first time as soon as it essentially creates the child. And then you can specify properties. Oops. First, I need to create the event, which I haven't done. So in that child changed event handler, hold on one second. That should create it, but I will create it instead. Let me make sure I get the name correct. And then, so then what I can do here is I can essentially get that object. In this case, I want my text block object. And I can specify properties on it. And so what I can't do, again, I need to add the using. Whoops, did I get it? Cool. What you can't do in WPF text blocks is emojis, which is kind of sad. You have to do some custom work just to get that to work. Like if I were to do, for example, text, just a normal text block, text equals taco, Scott Hanselman's favorite emoji, for those of you who saw the keynote. This will give me squiggly saying that it can't work, or at least it was the other day. I think we're in a goofy state with preview tools. But anyways, let's create the package and see this update behind the scenes. So I'm not going to run this. To my own chagrin, this is a little bit of a risk. You should always test your code. And then the next time I launch that same application, it's going to check for updates behind the scenes. There are package manager APIs you can use as well. I did make a mistake. Oh, that's why. I was missing the using statement. Let's build it and then package it. I think I messed up the event handler, so let's let Visual Studio create it for me. Apologies, there we go. Now I think we are in a better state. The app built, will the package build? Cool, sorry about that. So when I create this package, what the app is going to do on launch is it's going to essentially leverage underlying Windows services to check for an updated version of the app based off of the package version. And then when it sees that update, the next time the application closes, it's just going to install it behind the scenes. If you do need to force updates or do more advanced deployment logic, there are a set of package management APIs built into Windows 10 that you can consume in your code startup logic to check for applications or things like that. So once this finishes building, so again, what's going to happen is I'm going to launch this application, and you won't see any change because it hasn't actually checked for the app yet. Again, you could also check every hour, and then it would actually do it the next time you launched it an hour later. And so now I'll close it, I'll wait a couple seconds, and then the app will be updated. So just like that, now you see the same exact app, but now I actually have that Windows 10 text block using a custom XAML island control with the XAML host, with emojis, with automatic updates, all the Windows 10 goodness and stuff in a WPF application with minimal work. Great. And so last, but oh, sorry, I'm skipping ahead of myself. So to recap that demo, we have tooling in Visual Studio with the Windows Application Packaging Project and this package wizard to help you create these packages, and the app installer file is what it's called, that allows you to specify your automatic deployment and installer location settings. We're also adding new tooling soon to actually just create a template of that file so you can do more advanced scenarios by editing the XML. All it is just XML settings for your deployment. Again, going back to the case study, so we're working with Citrix. They're updating their WPF application with a whole bunch of Windows 10 stuff, but one of the things that's really valuable for them with the MSIX workloads is the ability to essentially enable their customers to deploy their application how they want. So they can pass in the MSIX to their customers with the signing cert that they may need, and then those customers can then deploy it however they need, whether it's through the store, or through SCCM, or through Intune, or however they need to actually deploy that application in their enterprise. In addition, we're working on a technology called MSIX Core, which will again bring a lot of this support down level. So lots of themes here. One is we're building everything with the community. Two is we acknowledge that a lot of the things we need to build have to go down level for you to take advantage of them. And so we're working hard to do that. But again, give us your feedback. Let us know what features you need and where, and that'll help us prioritize our investments to make the best solutions. So last, but certainly not least, is the agility to innovate at a developer pace. I'm sure many of you have been frustrated when you've wanted to take advantage of a new .NET Framework feature or a new language feature or whatever, and you couldn't because of the way your enterprise operates. But let me show you something kind of cool with .NET Core. And so I have this running application, and I'll show you one other little productivity trick. When you're trying to figure out where a package gets deployed, you can view details in Task Manager and just open the file location. I know there's sometimes this kind of ambiguous path with like the hash GUID and everything, but that's a great way to find it. And take a look at what's actually deployed side by side to this application. There's core CLR.dll. That's the .NET runtime that this application depends on. And so if I were to take this application and deploy it to any Windows 10 device that had the dependencies needed to run that XAML, basically, that's the only other Windows dependency there, this would run. So if you think about your own developer agility, when you do self-contained .NET, I mean, it's really up to you, however you want to do things. And so back to the slides. We did a lot. I know that was kind of fast, but what I want to say is we have booths for all of these at the expo, and the team is really excited to talk to all of you about this. So come find us. Whichever one of these 5 is most important to you, come talk to us about it and give us your feedback. And so this is a slightly different slide. It may look the same, but if you want to grab a picture, this is the how. So those sub-bullet points are what I did at each step of the way. And we just did all of that in about 25 minutes. So we did custom XAML islands, wrapped XAML islands, we did MSIX packaging, we did self-contained .NET. All of these things brand new with .NET Core and all of the Windows 10 work we're doing so that you can take existing .NET investments and existing .NET desktop applications and bring them forward to 2019. And with that, I'm going to pass it off to Olia, because obviously we talked about .NET Core a lot. So how do you get from framework to core? And that's what Olia is going to share.
Yeah. Great. Thank you, Daniel. Thanks for telling us about all the great features that are coming with .NET Core 3. And for your new applications, we definitely recommend to target core. But what if you already have a WPF or WinForms application that you have written some time ago, so you are targeting .NET Framework, and now you listen to Daniel, you probably saw keynotes, and you're thinking like, oh, I want all those great features too. Like, how do I enable them for my application? Do I have to rewrite everything from scratch for core? Well, no. You can take your framework application and retarget it to .NET Core. In most cases, it's possible, and now I'll tell you how to do that. And before starting doing anything that has a name migration, I like to ask myself this question. What can possibly go wrong? Right? Let's think about it together. So we will take an application written for .NET Framework with a .NET Framework API set, and we make it retargeted to .NET Core with .NET Core API set. What problems can we encounter? Ideas? So as you probably know, in Framework, we have a large set of APIs. Some areas that are deprecated, we did not bring them to .NET Core. Some areas were architecturally very hard to bring to core. So .NET Core has less API. When I say APIs, pardon myself, usually people think web APIs. In our team, when we say API, we mean everything .NET type members, so it's classes, types, properties, everything that we call APIs. So pardon my language. If we take our framework application, retarget it to core, it might happen that our app is using something that is not supported in .NET Core 3. And in that case, our application will break. Most of WinForms and WPF stack we brought to core, but if you're using something else like Click Once or WCF service, that won't be available in core. So that will break your application. Would that be an amazing idea to learn if my application is compatible with .NET Core before I start tearing apart the project file? But probably yes. And there is a way to do that in just a few clicks. Do you guys know how to do it? Any ideas? Do you, Daniel, know?
Yeah, I think so.
Go ahead.
The portability analyzer, right?
Yes, exactly. It's portability analyzer. Portability analyzer is available at this link. It will take you to the blog post that describes what the tool does and how to use it. But let me just show you. It's super easy. And let me go ahead and show you Portability Analyzer in action.
And so the Portability Analyzer is a .NET Desktop application, right?
Oh. Sorry, what?
This is a .NET Desktop application, right?
Yes, it is. It is WinForms application.
So let's play another game. Guess the runtime. As Olia goes through and uses the Portability Analyzer tool, try to figure out if it's .NET Framework or .NET Core.
Good idea. So once you go to the blog post, you download Portability Analyzer, you will get these files, you run executable, and this is the tool. And this tool is asking you for the path to your code, and I'll just provide. As a sample, I'll take paint.net. It's open source, amazing project. Let me get that. So I downloaded paint.net. I got Portability Analyzer. I'm going to click Analyze.
So who thinks it's Framework? Who thinks it's Core? If you said Framework,
Yes, it is framework. And the reason it's framework because when I was writing it, WinForms was not available for .NET Core. But now I probably should port my portability analyzer. So as you can see, it's already done analyzing, and we can click Open Report, which will open the portability report in Excel, but it's a CSV file. OK, I apologize. I probably should duplicate instead of extending. Let me fix it really quick.
So for those of you who are a little confused, the reason you could tell that it's .NET Framework is because we're calling that folder picker dialog. And in Core, we updated it so that it uses Explorer. In Framework, it's still the tree view. So that's the giveaway.
Yep.
Oops. Some resolution setting needs to be
And
fixed.
that, of course, set resolution to my default surface resolution.
1920 by 1080 is the second one. There you go. Cool. That's better.
Perfect. All right, so let's take a look at our portability report. On the left side, you see all your assemblies. The second column says what you're targeting right now, and it's .NET Framework. You were absolutely right. And on the left column, it shows you how compatible you are with .NET Core 3. If you have a green light and 100% compatibility, you're good to go. If you have less than 100%, then you should go to details and see what exactly is not compatible with Core. And for Paint.NET, we can see there are 3 types that are not present in .NET Core. So before going to port, you will have to refactor your code around those APIs. That's one case. I want to show you another case. So in the case I just shown, all assemblies were my assemblies, or Paint.NET. Now let's take a look at the project that has NuGet dependencies. And for that one, let me run Portability Analyzer against Portability Analyzer, against itself.
That's how you know your tool is good, when you can use your tool on your tool.
Right. OK, let's open the report. Here you go. So I see some yellow light, and I think, oh, I'm probably not compatible. But before giving up on all hopes and dreams, let's take a closer look. And this is my assembly, Portability Analyzer. It's 100% compatible. I'm good to go. And this one is an unit framework, because I have a dependency on in unit in my project. It shows that it's not 100% compatible, but I will go to this NuGet package. Oh, that's where it is. And I'll look, OK. So it actually supports .NET Framework, .NET Standard, and .NET Core. So that means the reason I got not 100% compatibility is because my application is on Framework. So it got NuGet Framework version. But once I point my application to .NET Core, package restore will pull up .NET Core and unit package, which will be fully compatible. So in this case, I'm good to go and can go ahead and port my application. And let me switch to slides. All right, so that was Portability Analyzer. And now, since this is our tips and tricks, I want to share some lessons learned. They are very trivial, but we tend to forget about simple things. And if we do, it might cost us a lot of time and effort in future. So trivial checklist. First thing, when you're going to port application that has many projects, start with the project that has no dependency on other projects, and then move up. Consider updating your NuGet packages. If your application is old, it might use old versions of NuGet packages. And those versions might not have support for .NET Standard or .NET Core because they were created before .NET Standard or .NET Core came around. So if you suspect that is the case, go ahead and update all your NuGet packages to the latest version. Use source control, or at least have a safe copy of your initial version of your application that you know it works. A migration requires editing your project file. And at some point, you might want to go and consult with the initial working version. And if something goes wrong, you need to have a safe copy to go back to. And of course, do one step at a time, build and run. If something fails, you will know for sure what exactly caused that fail. And with that, after I said all that, it might seem that porting is a very complicated, time-consuming process, but it's actually very simple. Porting to core means changing the value of target framework from .NET Framework to .NET Core in your project file. That's what it is. There is one trick to it. If your application has an old-style project file, then you need to first update it to new style project file. We call it SDK style project file. And let me just go to a demo and show you what is old and new project style files are. So for my demo today, guess what we will be porting? Portability Analyzer.
It's about time.
Yes. Thanks, Damien.
No problem.
So first, step 0, run Portability Analyzer. But we discovered it's compatible with Can Go Ahead. Step 1 is to see if your project file is old style or new style. And if you created the project for .NET Framework and you haven't touched it, spoiler alert, it will be old style. The way how I can learn about it, I can right-click on my project, and if I don't see update, edit portability analyzer.cs here, it already means it's an old style project. To be able to edit the project file, I first need to unload project and then edit portability analyzer. Okay, when I take a closer look to my project file, I see it's a very large XML file, and it has weird properties like project GUID and so on. So I know it's old project style. I need to update it to the new project style. The way I'm going to do that, first I reload the project. First thing, I want to look for a file packages.config. Because, oh, that's interesting, Zoom. Let's try one more time. All right, packages.config. That's where we use to store all your package dependencies. In the new project style files, we put the information in the project file instead of separate file package.config. So to not lose my packages, I need to move that info to my project file. Luckily, there is a tool for that in Visual Studio. I right-click on packages.config, and I choose migrate package.config to package reference. And all the job will be done for me. It will show you the report. Awesome. And as you can see, that file is gone. And now when we take a look at our project file, yes, I want to save changes. And we scroll all the way down. Here you can see I have my package reference and unit. So we put all our package references into project file, which is great. OK, now I'm going to update my project file to latest version. For that, I'm going to save a copy just in case in Notepad file. Now I'm going to delete it all. And instead of all that large ugly XML, I'm going to insert just those 8 lines of code. So this is the new project file style. That's all that's needed. It's much easier to work with. It's leaner. It's nicer. How do I know those 8 lines? Well, I happen to know that, but to get those lines, you can just create a new project targeting .NET Core. So if you have WinForms, create new WinForms on Core, WPF on Core, create the Hello World project, look at the project file. Those are lines that you need, right? So what do I need to add to my project file? Information about dependencies. First, dependencies on my packages. And for that, I will go to the copy. and I'll scroll all the way down where my package references are. I'll copy. I happen to have just one, but you copy every entity for package reference, and you just add it to a project file and save. Now, my application has only one project, so it doesn't depend on other projects. But if you do depend on other projects, you do exactly the same thing for project reference. Instead of package reference, you search for project reference, you copy and paste everything from your old project file to your new one. Now I'm going to save it, reload the project, keep my fingers crossed, and yeah, let's try to build and run it. So what we just did, we updated all project style to the new one. OK, awesome. It works. Great.
That's still the old tree view, though.
Yes, yes, it is because we're still on framework. But now we are ready to port from framework to core. And that's how we do it. Now I just double-click on the project. It opens right away, so I don't need to unload, reload my project again. And I go to target framework. Instead of Net 4.7.2, I'm going to use Net Core App 3.0. I will save this. And I'll do rebuild because I want package restore to pull up the core version of NUnit. Let me now run it.
And so now this should just run better, right?
OK, so are you ready for it? Ta-da! So as you could see, the porting itself was extremely simple. Let's go back to my slides. Yeah, and once you ported your application, you can benefit from all the features of .NET Core 3. But there's one thing, the designer, WinForms designer, is not ready yet. It was a lot of work for our team to re-architect the way WinForms designer will work out of Visual Studio process. And we're working on it right now. It's coming. But for now, you cannot use WinForms core designer. But there are ways how you can still use the traditional framework designer and have your application on core. And you probably saw Scott Hunter doing it. I will not demo it, but if you have questions, we're at the booth. Come up to us. We'll gladly show you. I'll just quickly recap. There are a few ways how you can do that. Option 1, you can have 2 projects that are linking same files. So for example, you have your .NET Framework full project. You create a new .NET Core project. You link all the files from your framework application to this new .NET Core project. That way, when you need the designer, you just go to your framework application and work with the designer, work with UI. But when you build to core, you have all the features for .NET Core. And of course, once you edit files in one project, their changes automatically get translated to the other project because they're sharing same files. Another option is to have one project, but 2 project files next to each other. One project file will have .NET Framework as a target, and the other one will have .NET Core. That way, you will unload and reload the project with the project file that you need. If you need the designer, load the application with your project file that is targeting .NET Framework. For everything else, load it with .NET Core project file. And few more tricks before I go back to Daniel. If you ported your, if you ran Portability Analyzer and got a green light 100%, then you retarget it to core, and you see that something is missing, you can get that from a NuGet package called Microsoft Windows Compatibility. This Compat pack has more than 20,000 APIs that were not included in .NET Standard, but helps you to migrate to .NET Core or Standard and still keep using those APIs. So if you're missing that, it's very easy to add those. And if you added that in your libraries, and you're thinking about reusing these libraries maybe for future, for your maybe not Windows Forms or WPF user interfaces, but maybe you come up with Xamarin or like Android, iOS UI, and you want to reuse the library, and you used Windows compatibility pack in your library. What problems may you encounter in this case? Any ideas?
Platform not supported exceptions?
Yes, that can happen because Windows compatibility pack has cross-platform and Windows-only APIs. And if you're using it for your library, and then you want to use that library for Android or iOS project, you will get platform not supported exception. So to be informed about all those usages, if you're installing Compat Pack, also install API Analyzer. API Analyzer is a Roslyn analyzer that will squiggle out all APIs that are not cross-platform, and also it will prompt you about deprecated APIs. So it's like a helper that sits behind your shoulders and gives you tips. And as any Roslyn analyzer, it's very customizable. If you don't want to see some notifications, you can set it up. So don't prompt me about Windows suites. I don't want to hear anything about it. I made my peace with it. But for example, this exception, I want you to give me a build error. I don't want my code to compile if I'm using that API. You can do all that. And everything that I just said is available in our instruction on our .NET blog. It's called Step-by-Step Porting Guideline. And next week, I will publish another instruction that will be called 3 Steps to Migrate. So look at .NET blog for more documentation. And with that, I give it back to Daniel. Thank you.
So let's talk about our roadmap. We just released .NET Framework 4.8 a few weeks ago. There's some value there for existing applications. This should be a really easy update, assuming your enterprise or your customers have .NET Framework 4.8 installed. Yesterday, we released .NET Core 3.0 Preview 5, as well as Visual Studio version 16.1 Preview 3, and that's a lot of versions. Those two tools together would be the best combination for support for building .NET Core desktop applications. Everything is in preview, so we're working hard to make it more stable and improve it or as time passes. And then the actual .NET schedule. So you may have seen this slide from Scott Hunter. .NET Core 3.0 will GA later this fall with a stabilization release shortly thereafter for long-term support. So 3.1 will come in November, meaning if you do need that long-term support guarantee, porting to .NET Core 3.0 and then just retargeting to 3.1 is a good kind of step forward. And then going beyond that, we're getting into a more rhythmic cadence for releasing .NET. Every year, we will have a new major release, and every other year will be a long-term support release. So you have essentially that knowledge going into it when you target a version of .NET, how long it's going to be in support, and what sort of capabilities it has. In addition, WinForms and WPF. Our short-term goal is to finish open sourcing the rest of the code. There's still some stuff missing from WPF, but we're working hard to get that on GitHub. We want to bring those platforms to functional parity with .NET Framework, so everything that worked in WinForms should work the same, or WinForms and WPF should work the same or better, as you can see with that folder picker dialog on .NET Core. Then we want to complete and polish the tooling experiences, including the designers. And then from the platform, we're on GitHub. We're working with the community to figure out what would result in the most value to these customers going forwards. So let us know, comment on issues, file issues, engage with the team. If you really need a fix, the team is incredibly responsive. There's this story, we filed a bug one day, and I think like literally the next day it was impacting a partner. We had a fix out from a daily build, ready to go. So if you do hit those issues, let us know. We'll probably get you a fix really quick. Some related content, if this stuff is important to you. I believe the only one that hasn't already happened in person is DevOps for applications running on Windows, which is tomorrow. If you want to go into more depth on creating a continuous integration and deployment pipeline for building Windows desktop applications, that's a great one to go to. State of the Union, the Windows presentation platform, you can watch recorded. That'll go into more detail about how they plan to decouple XAML from Windows, and so that you can essentially take advantage of whatever version of that libraries you want. Again, don't think of WinForms, WPF, and UWP as the platforms. Those are UI frameworks. Windows is the platform. And then there's more. If you search for those search terms on the build website or through the app, you can find more. Last but not least, a sneak peek into what's coming up. This is going to be around the 3.0 GA timeframe, a free virtual online conference. So get more information at .netconf.net. And this will probably have more details about what's coming beyond GA, because this will be right around GA. With that, thank you so much for being an amazing audience. We have exactly 5 minutes. We wanted to give you an opportunity to ask any questions. And if you don't mind, I may take a selfie with all of you, because this has been an amazing audience. So everyone, on the count of 3, say .net in just a second. What's up? Framework or core? You can say your favorite. Sorry, my camera's being goofy. I want to zoom out, but it's not letting me. Whatever. Everyone say .net. 1, 2, 3.
Oh, come on.
Sorry. Thank you. Any questions?
Thank you.
Question? If you have an old framework application using legacy controls, how do you migrate the application? So we have been proactively working with many of the top component and controls vendors to already support .NET Core. That said, especially UI-based components, most of them will just be compatible. A lot of times they will not be calling unsupported APIs. And there is limited .NET Core consuming .NET Framework compatibility support. So it might just work. If it doesn't, that component vendor knows about .NET Core, and they're working hard to update it. Great question.
Right. Yes.
Yes.
Diagnostics debug is not supported. What to use instead of debug?
What do you mean diagnostics and debug?
Well, when you run analyzer, system diagnostics.debug.
Oh, system.diagnostics.debug is an unsupported API in .NET Core. What's the right one to use instead? Do you know, Ilya?
That is a great question. Actually, I will follow up with the team. And,
If you stop by the .NET Framework booths in the expo, someone there will definitely be able to provide the alternative.
Or you can send us email and we'll respond.
How is the decoupling from the platform or the UI from platform and Windows Server going to work? That is also a great question. I think they will provide support for Windows Server 2016 Service Pack something. There's a XAML booth at the expo where they would be able to answer that.
How much coding change is required from the .NET Framework?
The question is, will click once not be supported? That is currently how we're operating. We've been getting a lot of feedback on this one, so we may reconsider that decision after build. But
And we wanted to migrate in a .NET Core. So what do you anticipate from the coding change perspective?
sure, if click once is unsupported, what's the path forward? You can use installer projects. You can use MSIX, what I demoed here. And the MSIX team with MSIX core down level support is trying to provide functional parity and better experiences with MSIX. So that would be the ideal.
Should we get our mics muted or?
We'll get our mics muted in 2 minutes. People may want to hear.
Okay. So I think it really depends on the API sets that you are using. You can write portability.
The question was, when will I get an option to compile everything as a single executable? I believe that is 3.0. We're working on that. Yes.
If you have some particular questions, you can send me email and I'll give you a particular answer. Because in general,
Okay.
sure, yeah. So it's OLI.
Some point in the future, there will be a simple way to do data marshalling and interoperability. What's the time frame? Is it true?
The question is, data marshaling between native assemblies in .NET is difficult to do. What's the time frame for improvements there? Again, I'm not 100% certain. The .NET Framework booth would have someone there that would be able to answer that one at the expo. Yep.